SSE is proud to operate the innovative and low-carbon Wandsworth Riverside Quarter heating and cooling network on behalf of our long-standing client, Fraser's Property UK. For SSE, though, the heating and cooling network at Wandsworth Riverside Quarter is one piece of a large and growing portfolio of networks that we design and operate across the UK. Like all heat networks, the Wandsworth Riverside Quarter network is designed to deliver three key benefits. Carbon savings. The network is providing a 40% carbon reduction in comparison to a conventional gas-powered system, and we expect to improve on this performance through further system optimization in the future. Energy reduction. Since adopting the network, we have recommissioned the control of the system in order to reduce energy usage, optimize temperatures, and improve reliability. Affordable charges for customers. Annual heating charges for customers at Wandsworth are lower than they would be for a customer with traditional gas boiler heating. So, what is the Wandsworth Riverside Quarter heating and cooling network? It is a mixed-use development on the banks of the River Thames in London. It encompasses 12 buildings, 6 of which are served by an innovative, low-carbon heat and cooling network. This includes 547 residential premises and 31 businesses, as well as a swimming pool and gym. The low-carbon heating and cooling is provided from energy recovered from the aquifer, which is water deep underground, directly beneath the site. The development was built in 2 phases, with an energy strategy carefully designed to enable the low-carbon heating and cooling system to expand as new buildings were completed. How does the heating and cooling network operate at Wandsworth Riverside? Instead of having a gas boiler in every home and business, there is a network of pipes across the site which is fed from SSE's Central Energy Centre. This pipework distributes heating and cooling between buildings and into each apartment and business. The system at Wandsworth Riverside comprises 3 different networks, circulating water at different temperatures to homes and businesses. First, we have a cooling network, circulating cold water to provide air cooling for properties. Next, there is a warm water network to provide heating to properties. Finally, we have a hot water network, circulating water at a higher temperature to provide hot water to properties. In order to generate this low-carbon heating and cooling for distribution, the Energy Centre contains a mix of different technologies. Firstly, and most importantly, there are 3 heat pumps. These extract energy from water drawn up from the rock below the site, known as an aquifer. Water from the aquifer is pumped into the heat pumps, where they either extract energy from the water and transfer this to hot water for heating or cold water for cooling. It's important to know that all the water extracted from the aquifer is returned, meaning there is no depletion of the volume of water in the aquifer. The heat pumps are powered by electricity either generated on-site or via off-site zero-carbon renewable electricity. The heat pumps work in tandem with a combined heat and power unit which burns gas to generate electricity and captures the heat that is created as a byproduct of the generation process for use in heating and hot water. The CHP is an additional heat source that we operate to provide heating and hot water at Wandsworth Riverside. The CHP generates electricity which provides the power for the whole system, particularly to operate the heat pumps and make the site as self-sufficient as possible. When the CHP is not generating enough electricity to meet the requirements of the site, we import electricity from the grid supplied from 100% SSE renewable sources from wind farms and hydroelectric power stations. Within the Energy Centre, we also have a thermal store, which stores hot water like a giant battery. The thermal store, which is a large hot water tank, is critical to the network, storing energy when it is not needed by customers and releasing it when it is. This enables us to generate the energy when it is cheaper to do so, and in turn, we can pass these cost savings on to customers. Next, we have the gas boilers to provide backup and resilience to the scheme. The gas boilers only operate when the CHP cannot meet the entire hot water demand. Then we have the electric chillers to provide top-up cooling if needed. The chillers operate when the heat pumps cannot meet the entire cooling demand, just like gas boilers do for hot water demand. Once heating and cooling has been generated in the energy centre, distribution pumps move the hot, warm and cold water around the system to where it is needed in each building. Then, in each home and business unit, we have a heat interface unit and a cooling interface unit. These take the heat and cooling energy from distribution pipes and transfer this to the customer's own heating and cooling system. They enable customers to have complete control of their heating and cooling systems 24 hours a day, just like they can with a traditional gas boiler and controller. The success of the project is down to the way the whole system is integrated and optimised to reduce carbon, save energy, and reduce costs for customers. Why is the Wandsworth Riverside Heating and Cooling Network special and innovative? The heat pumps are particularly sophisticated. They enable us to provide something called simultaneous heating and cooling. Put simply, this means they can generate both heating and cooling from the energy in the pipes, which is being returned from the buildings. For example, to provide cooled water for cooling, the heat pumps remove heat energy from the water in the system. This waste heat energy is then captured and used to heat the warm and hot water networks, providing heating and hot water to customers. This works just like the fridge freezer in your home. In your home, the waste heat radiates from the back of your fridge freezer, whereas in our system, this same heat is captured and used for heating and hot water for the site. The system can also work in reverse, by using the cooling effect created by heating the water to heat the heating network. This means that, for a large proportion of the year, the heat pumps can generate all the warm water for heating and cold water for cooling without the need for pumping any water up from below the ground in the aquifer. This is simultaneous heating and cooling. Only when customer demands are highest in winter for heating and summer for cooling do we need to import electricity from the grid and abstract water from the aquifer below the ground for the heat pumps. But there's more. We also make use of the energy storage potential of the aquifer beneath the site to further reduce energy and carbon across the site. To do this, we use a method called interseasonal storage. During the coldest winter months, when the network needs to produce lots of heating, it creates a surplus of cooling as a byproduct. This is pumped as cold water underground and into the aquifer and stored until it is needed in the summer. Then in summer, when we need less heating and more cooling, we can extract this cooler water and reject warmer water to the aquifer below the site, ready for abstraction in the winter. Another design innovation at Wandsworth is the fact that there are two heating circuits, one for hot water and one for space heating. Heat pumps are most efficient at providing lower temperature heat, so they provide the energy for the space heating circuit, whilst the CHP provides the higher temperature heat needed for hot water for sinks and showers. Many systems would only have one heating circuit, which provides both space heating and hot water. Each circuit, hot water, warm water and cooling water, is interconnected to provide resilience, backup and reduce wastage across each network. For example, the CHP, boilers and thermal store mainly provide hot water and electricity, but they can also contribute and top up the temperature of the underfloor heating, which is sourced from the warm water circuit. The process is highly efficient and minimises the use of electricity, which is important as in the future there will be more and more demand on our electricity grid as we reduce the use of fossil fuels and use more electricity for heating and electric vehicles. The thermal store, which is a very large water tank, works in tandem with the gas CHP. We top up the thermal store using heat from the CHP at times when demand on our network is low. When demand is high, typically in the morning and evening, we use the thermal store to top up the hot and warm water networks. The thermal store acts like a hot water battery and in combination enables us to reduce our electricity demand from the electricity grid. Having a CHP on site means that we can generate electrical energy locally, which then feeds the heat pumps. CHP-generated electricity is cheaper than electricity from the grid and, if run in a smart way, can be lower carbon than grid electricity. By supplying heat pumps with electricity directly from the CHP whenever it is operating, this helps ensure the lowest cost and lowest carbon heating and cooling for our customers on site. In order to monitor the integration of these systems, we control and optimise all of these different technologies from our UK SSE control centre. For a large proportion of the year, we can operate the CHP to provide just enough electricity to meet the electricity demands of the heat pumps, whilst also providing enough hot water for taps and showers without any contribution from the gas boilers. The boilers are a higher carbon form of heat production, so it is important to minimise their use. At SSE, we believe that heat networks are a crucial part of the UK's transition to zero carbon heating. They enable us to capture energy that would have otherwise been wasted and provide it to our customers at affordable rates. Wandsworth Riverside Quarter provides a practical example of smart, integrating, low-carbon, affordable energy, which helps point the way to a zero-carbon future. If you want to know more about our other heat networks and integrated energy offering, please visit our website. Search SSE Energy Solutions, Heat and Cooling Networks. Thank you for watching.